Okay, good morning. Welcome to
FamilyMath977.
FamilyMath977. So we have been studying a shape over the last week called what?
Permeate.
And what is the permutahedron?
So you create it by taking a set of numbers and you basically permute them. So it's like this one, you take the set of numbers 1, 2, and 3, and you order them differently.
Okay.
That creates the coordinates. So
All right, I'm going to zoom in. All right, so that's...
this back corner is 0, 0, 0.
Okay.
And for example, the point, so I think this direction is x, this direction is y, and going up is z.
Okay.
So the point 3, 2, 1, for example, you go 3, 2, and then 1.
Nice.
So you go up like that.
Okay, cool. And what's interesting about this permutahedron?
It's created in a three-dimensional space, but it turns out to be a two-dimensional shape.
Okay, can you show me the two-dimensional shape?
So tilt it up.
Yeah, just put it a little bit forward. Okay, ooh, good. Yeah, that's nice. Okay, so it's a two-dimensional shape, and can you rotate it sort of on the edge 45 degrees? Just like, yeah, it helps see it. Yeah, that's good. Okay, so one of the things that we can do to study higher dimensional shapes, I'm going to zoom out just a little, is we can take slices of them. So you can imagine projecting this plane here that the hexagon is in into the XY plane. Right?
Mm-hmm.
Forward. Come all the way so you're up here by my feet. A little more. A little more. And now we're going to we would take slices in the XY plane so that this would be the lowest point in the plane, in the XY plane. This middle here of the hexagon would be the center. So 0, 0, 0.
Yeah.
And so if I did a slice just like this, how many balls of the permutahedron would I hit?
Like 1.
Okay. And as I move that up, sort of perpendicular here, but coming up through the center, how many do I hit next?
You get 2.
2, and then I pass through the center, and then I hit
2, and then back at 1.
So if I was passing through this with a line, I would first hit 1 point, then 2, then 2, then 1.
Yeah.
And the interesting thing is the 2's that we're hitting are not connected to each other, so it's not like there's a line through them.
Mm-hmm.
But that would help us understand what the shape was like. So what could you say, like if I told you that this had this 1, 2, 2, 1 feature to it? What are some things we could say about that shape?
Well, you could say it has 6 vertices.
Okay, yeah, definitely we could say it has 6 vertices.
You could say it has some sort of symmetry to it, like down the middle.
Okay, that's interesting. How would you know there was symmetry to it?
Well, if you're taking the slices at kind of equal intervals, you might know that it would have some symmetry.
Okay.
But if you're just taking like 1 here, 1 there, 1 here, like if the intervals weren't equal, you might not know that there's symmetry.
Okay, yeah, you might see the symmetry, you might not be able to see, but it starts to look like it has some symmetry. Okay, what do you think? Could we say anything else?
Well, if you're taking slices on the same plane, you know the shape is two-dimensional.
Mm-hmm.
What else could you say? I think if you, like what he said, there might be some symmetry, but I think it also could be going like this.
Ah, okay, interesting. So you might see one kind of
symmetry.
symmetry, but maybe not another.
Yeah.
All right, cool. All right, so now we're going to look. We've made the 3D projection of the 4D permutahedron. So this is the permutahedron on 3, permuting 1, 2, and 3.
Yeah.
And that lives in 3-dimensional space, but it projects down to 2-dimensional space. And we've made the one permuting 1, 2, 3, and 4 that lives in 4-dimensional space, but projects down to 3-dimensional space. So we're going to look at that next.